Hello everyone, as we are getting close to revealing the final product that we have been working on, we thought of sharing some of the insights in making of these parts. For this, we have started a new series of videos which we are calling as Lapa Insights. In this video, we'll be discussing about the carbon fiber monocoque chassis of the scooter. So let's get started with it. So here we have with us a small piece of carbon fiber composite, also known as just carbon fibers. It is a pretty exceptional material. Just imagine something as lightweight as plastic, but still as strong as steel. For the same weight of steel, it is almost 5 times stronger. Now that you're imagining, I want to show you how carbon fibers actually look like. So here we have a toe of carbon fiber. This toe is made up of thousands of fibers, and each fiber is around 10 times thinner than human hair. To get from this to this, it's a very complicated process where you have to mix the carbon fibers with resin and you get this strong composite. Now you must be wondering why I'm calling this as a composite. So composite is nothing but just a mixture of two or more materials together. For an example, cement mixed with gravel and iron rods is also a composite. Carbon fiber composites are generally used in spacecrafts, fighter jets, and supercars. Here at Lapa, we have made the frame of the scooter with this material, and it is the outer body of the scooter that is made up of it. This kind of structure is also known as monocoque chassis. This has allowed us to have a lot of space inside the scooter. That means we can use that we can have a little bit extra weight in other parts of the body. For an example, batteries to get that extra range, or motor to get a little bit higher acceleration. So everything started with a design, and since this is an outer body visible to the eyes, we followed the traditional G2 G3 continuity for the Class S surfaces for better aesthetics. So once that is done, it is very important to decide and lay down the fibers in a specific direction. These fibers provide the maximum strength in the direction of fibers. And these fibers come in a different weave pattern, as you can see here. And it is also very important to decide the number of layers that you will be using in your structure. Once the design is complete, it goes through a computerized simulation process where we put up some virtual loads so that we can mimic the harshest conditions that a scooter will go through in the real world. Now, as per the simulations, the scooter body can take weights up to 700 kgs, whereas the normal scooter limits are in the range of 250 to 300 kgs or a maximum of 400. In future, we'll be bringing the real-world videos of the test done on it. But just to give you an idea, this material is very durable. It doesn't corrode, rust, or age with time. It is also stiffer than most of the metals. So the response that you get from the road is very organic and very natural. And you also do not need to worry about accidents, since this scooter body is strong enough to not break in case of accidents. It is it is a different issue in case you want to, intentionally crush it between two trucks or two cars. So let's come to the manufacturing part. So we have Mr. Bharat with us today. He is taking care of operations in the manufacturing department. So I'll just hand him over and let him explain the manufacturing process.
So there are different methods and techniques to manufacture composite parts based on the end use case requirements. Once the design is finalized following simulations and validated, so then the manufacturing of proto parts will start. Choosing best suited method and materials will play a crucial role in manufacturing of proto sample. Here at Lapa, we have opted a vacuum infusion technique, which is widely proven in major fields like aerospace, performance, sports, automobile, and turbine manufacturing. So we have taken all the measures to avoid any defects in the parts, to make sure it is defect free and there won't be any structural failures. So even a vacuum infusion method is a best proven method widely in different areas. It will consume more skilled manpower, and also it's a time consuming method. So presently we are working on high pressure resin transfer mold technique, where we can reduce the cycle time very drastically so that we can manufacture a part in a very less time. So with the help of advanced machinery in RTM technique, there will be a very least manpower intervention, so we can assure best quality, repeated quality in every part manufactured in this technique. As of now, we are working on a CNC aluminum molds to get the parts, and in it we will be laying down different multiple layers of carbon fiber fabrics, and then we'll seal it with a vacuum cover. Then we will apply a controlled vacuum in between the sealing cover and the mold. So we'll make sure there won't be any air trapped inside the layers. Then from another end we'll connect the resin into it. So with the help of vacuum, the resin flow inside the multiple layers. After ensuring there are no dry areas in entire mold and complete fabric is soaked in the resin, the mold will be moved inside a controlled heating chamber, a oven, and it will be cured under predefined temperatures and the time. So once it is cured inside an oven, it will be taken out, and we have to remove the peel plate and vacuum bag, and then we can take out the part. So once we taken out the part from the mold, then it is moved for the trimming and other post-processing like drilling and for riveting and those kind of things. So once the part is moved for post-processing, for example drilling and trimming, so there are good chances for delamination, and which may cause reducing the strength of the part structurally. So we have taken good care to avoid such kind of defects in the part, and for example galvanic corrosion also. So it will happen if any metal will directly in contact with the carbon fiber surface. So we have taken good care to avoid these things to make sure the final part is well proven and processed. So these are the topics where we have to discuss in depth. So we can discuss these topics in next videos. Until then, wait for the next video. Thank you. Goodbye.